Good afternoon. Today we are on a new topic called Remainders Theorem and Factors Theorem. Now, Remainders Theorem is not the same as Factors Theorem, but you will find that it's kind of related. So I combine them and I find it easier to teach you all at one go. Now let us recall in primary school, you learn about division. Let's say we use a number 7 divided by 3. What is the answer? You will get 2 and remainder 1. So you can say that 7 is equals to 3 times 2 plus 1. Now, what do we call each of these things? This is called the dividend. Okay? And this is called the divisor. Oops. This is called, can you recall? In primary school, what do you call? You call that quotient. And this is called the remainder. Okay? Now you learn how to deal with numbers in primary school. In secondary school, you learn how to do with polynomials. Now let's say a polynomial p of x is divided by ax plus b. And then you will get a quotient, which is also a polynomial, plus a remainder. Now, you find that in primary school, you find that the remainder is always smaller than the divisor. Excuse me. Now, when you divide polynomial, you find that the degree of the remainder is always smaller than the degree of the divisor. That means this one is of power 1, of degree 1. You take the highest power of x. Alright, that is the degree of the polynomial. So this is of degree 1. So this will be of degree 0. It's always less. Alright, so if it's always less, this will be a constant. Okay, so we can rewrite it as ax plus b into q1x plus r. Now let us increase the degree of the divisor. Let us increase to 2. Now p of x, if it's divided by ax squared plus bx plus c. This part will be q2 now. It's not the, oh no, it's not a plus, it's a times. Maybe I just erase this. Now this should be a times q2x plus, now this is power 2, alright, degree 2. This must be degree 1. So will be like maybe px plus q. So it is in terms of x, alright, it is a function of x. So I will just write it as rx. Now, show you one more. If I divide by degree 3, ax cubed plus bx squared plus cx plus d into q3x, then this one will be, maybe it will be r1x. All right, this is not the same, not the same. Now this is of degree 3, this one will be of degree 2. Alright, this is degree 2, this will be degree 1. Now, what we are interested today is more of this. Okay, this one. Now, let us substitute x is equals to minus b over a. Alright, how I get minus b over a? Alright, I equate this to 0, ax plus b, equate to 0, so I get minus b over a. Let's substitute minus b over a into this expression. Now, then you will get p of minus b over a. Then you have a times minus b over a plus b q1 of x plus r. Now, let's look at this term. Now, this one I cancel off. What will I get? I will get minus b here. Minus b plus b, it will be 0. Alright, that means p into minus b over a will be the remainder. So that is what remainders theorem is all about. Now that means if you have a polynomial and you are dividing it by a linear expression like ax plus b, then all you need to do is you substitute minus b over a into your function, into your polynomial, and that will give you the remainder of the polynomial. Now, so let's put remainders theorem in words. Now, remainder theorem states that if a polynomial p of x is divided by ax plus b, then its remainder becomes p of minus b divided by a. Now, that is remainders theorem. Then what is factors theorem? Factors theorem is, now if p of minus b over a is equals to 0, that means the remainder is 0, that means there is no remainder, then ax plus b is a factor of p of x. Question number 1. Is 6x cubed plus 13x squared plus 3x plus 20 divisible by 2x plus 3? We can do a long division and see whether the remainder is 0. But that is long and tedious. But we can also apply remainders theorem. Now, let p of x be equals to 6x cubed plus 13x squared plus 3x plus 20. Now, we equate 2x plus 5 to be equals to 0, and we find that x is equals to minus 5 over 2. Then we substitute minus 5 over 2 to replace x and check whether the expression equals to 0. So you got 13 into minus 5 over 2 square plus 3 minus 5 over 2 plus 20. Now you can key this into the calculator and you will find that this is equals to 0. Alright, hence the expression 6x cubed plus 13x squared plus 3x plus 20 is divisible by 2x plus 5. So the answer is yes. It is divisible. Okay. Now let's move on to number 2. Now in number 2, it states that if ax cubed plus 2ax squared plus 3x minus 5, when divided by 2x minus 1, the remainder is 2. You are asked to find the value of a. Now, how to find the remainder when that expression is divided by 2x minus 1? So again, we can use remainders theorem. Say f of x be equals to ax cubed plus 2ax squared plus 3x minus a. So when it's divided by 2x minus 3, the remainder is a. That means f of half, alright, you substitute half to replace x. Now, so you got a into half cube plus 2a into half square plus 3 into half minus a. This must be equals to 2 according to remainders theorem. Okay, if you simplify this, you will get minus 3/8 over a plus 3 over 2 is equals to 2. So you find that if you solve this equation, you will find that a is equals to minus 4 over 3. Now question number 3. Now you are asked to factorize x cubed plus 6x squared plus 3x minus 10. That means before that we need to find at least one factors of this. Now how to find the factor of this? Now is by trial and error. Let's say f of x is equals to x cubed plus 6x squared plus 3x minus 10. Now, what we normally do is we put x is equals to, these are the values that we normally try, all right? 1, minus 1, 0, minus 2, and 2, and see which one will give you 0. All right. Now because they won't set the question, all right, that the factor is x minus 3 over 8. That is crazy. Okay. So what they do is they normally will not make it so tough. Okay. Now, so let's try f1. F of 1. You got 1 cube, which is 1, plus 6 plus 3 minus 10. You find that this is 0. What does this imply? According to factors theorem, it means that x minus 1 is a factor. X minus 1 is a factor. Okay? So we can write it as, we can write x cubed plus 6x squared plus 3x minus 10 will be equals to x minus 1 into ax squared plus bx plus c. Now because this is power 1, in order to get an x cubed, this must be 1 power less. all right, 1 degree less, I mean. Now, so you look at it, this is 1x cubed, all right, 1x cubed. Now, how can you get an x cubed when you multiply out? This is the only way that you can get an x cubed. This way, all right? No other way you can get an x cubed when you multiply. So by comparing coefficient, you will have a is equals to 1. Now then you look at minus 10. Only this way you will get a minus 10. You multiply any other term will involve x or x squared and so on and so forth. Only this one. So you have minus c is minus 10. So you have c equals to 10. Now, then how to find b? Alright, just now we reuse up this term and this term. Now, so we can compare the coefficient of either the x squared or x. Perhaps I just choose x, okay? Now, so you have 3. 3 will be equals to what? Now, you look at this, which one will give you an x term? This one will get you an x. And this one will give you an x. Okay? So 3 will be equals to minus b plus c. But what is c? C is 10. Alright? So you will have 3 is equals to minus 10 or plus 10 minus b. Okay, so b is 7. B is equals to 7. Now there's not much space. Okay, I try to squeeze it in. All right. So this will be equals to what? Maybe I just write it here. Okay. So f of x is now equals to x minus 1 into a is 1, so into x squared, b is 7x plus 7x, and c is 10. Alright, so this one you can further factorize it into x minus 1 into x plus 2 into x plus 5. Alright, so that is the answer to question number 3. Now we will move on to question 4, but before that I need to erase the board. In question 4, you are asked to find the remainder of x to the power of 2003 minus 1 when it is divided by x squared minus 1. Now this sum is a bit out of the norm, but if you understand remainders theorem, you can apply it. Alright, it is still not too tough. So first you have x to the power of 2003 minus 1. Now you want it, what's the remainder when it's divided by x squared minus 1? So this can be rewritten as x minus 1, x plus 1 times the quotient plus ax plus b. Alright, this is the divisor. Alright, and this is actually x squared minus 1. Alright, this is the quotient and this is the remainder. Okay, this is of power of degree 2, so this one must be of degree 1. Now, then you put x equals to 1. Now then you have 0 here, and this will be 0 as well. So you have a plus b. Next, we would like to make this thing 0 again by putting x equals to minus 1. Now minus 1, this is to the power of, it's an odd power. 2003 is odd. So minus 1 to an odd power will be minus 1. Alright, so minus 1 is minus 2. Now you put minus 1 inside here, so it will be equals to minus a plus b. Now let's call this 1 and call this 2. Now if you plus them together, alright, you will have 2b equals to minus 2. So b is equals to minus 1. Now when b is equals to minus 1, you put inside either 1 or 2, it doesn't really matter. Of course, this is easier, alright? Now you put b is minus 1, so a is 1. So what is the remainder? Therefore, the remainder is a is 1, so is x minus 1. Alright? So we have come to the end of this video. If you like our video, please press the subscribe button. Have a nice day. Thank you.